Up to this point, the Canvas Quick Start video series has focused on the venue activity, where you define venue geometry using guide layers and the drawing tools or importing geometry directly into Canvas. In this video, we will start looking at the features and tools available within the system activity, starting with adding Cohesion line array products to our system design. In this particular model, the production origin is defined as the downstage center edge of the stage, the most common origin for a touring production. Because of this, the venue model is centered on that point. Let's move to the system activity by clicking on the System Activity button at the left side of the application. This brings us a number of new view workspaces and tools that we can use to build out our Cohesion system for this project. To add a line array, subwoofer, or point source to your project, select the Add Sound Source tool in either the 3D System or Top View toolbar. From here, you'll be able to select from the available products supported within Canvas. Today, we'll be adding a Co-Series line array source, the Co12. Upon clicking, you are prompted to name the new source. And just like that, a symmetrical pair of Co12 arrays are added to the project. A few things to notice. First, the arrays are centered at X with the pair spaced 20 meters apart, roughly 66 feet. Next, the arrays by default are added to the project with a predefined enclosure quantity and array curvature. And finally, they are a mirrored pair so that when changes are applied to one array, they are mirrored in the other, with the symmetry being across the XZ plane. When a new source is created, it is automatically selected. The selected source is indicated by the yellow box in the Studio workspace and the blue highlight in the sources list in the multipurpose panel. Notice the pair of selected array sources are represented by a single entry within the system source list, and any changes or edits to the array's setup, processing, or configuration will be applied to both arrays symmetrically. The data field section of the multipurpose panel contains all of the editable parameters and configuration settings available for the selected source. Line arrays include 3 categories of settings. The Setup tab holds the physical settings of the entire array. The Processing tab allows you to define the processing that will be applied to the array. And lastly, the Enclosures tab allows you to configure the physical curvature and horizontal coverage of enclosures within the array. Next, we need to move the arrays into position to reflect where they will be deployed for our design. X, Y, and Z coordinates are editable and viewable in the Setup tab. Additionally, all sources can be moved directly within the model in either the 3D System or Top Views using the Move tool. If moving the object along a single axis, X, Y, or Z, simply hover over the axis you want to manipulate and click and drag to the desired location. If moving across multiple axes, select the square and move the object to its new location. Should there be an undesirable move, you can use the Undo and Redo tools in the lower right-hand corner of the workspace, or use the keyboard shortcuts. Control or Command plus Z for undo, or Control or Command plus Y for redo. Control or Command Z can be your friend here. The XYZ position defined for a source is directly related to the frontmost pick point for both flown line arrays and subwoofers, and the front-bottom edge for ground systems. By zooming into the top slider of the Co12 array here, we can see that the Move tool not only serves to manipulate position, but also defines the array origin in the 3D System view. When we manipulate the rigging parameters within the Setup tab, we can see that the model updates the array while maintaining the origin position. To adjust the horizontal and vertical aiming of the array, you can enter the desired aiming values in the vertical or horizontal aiming fields within the Setup tab. Horizontal aiming can also be adjusted in the Top View using the Move tool. Select a source and, while hovering over the horizontal rotation, click and drag along the arc in either a clockwise or counterclockwise direction to change the horizontal aiming parameter. Vertical aiming can be adjusted within the cross-section view by adjusting the aiming of the top enclosure within the array, indicated by the dashed orange line emanating from the top enclosure. Position the mouse over this line, and once the cursor has changed to up and down arrows, click and drag to adjust the vertical aiming of the array, using the 2D cross-section as a guide. Additional parameters in the Setup tab include the number of enclosures within the array and various rigging options such as slider position, pick point quantity, and positioning. Not all designs require symmetrical mirroring. Source pairs can be unpaired by turning off the pair within the Setup tab. Once the two sources are no longer paired, each is represented as an independent source within the sources list. The house right source will, by default, maintain the paired source name, while the house left source will be labeled with an M to indicate it was the mirrored member of the pair. By selecting the unpaired source in the workspace or sound source list, it can now be edited independently. To repair a selected source, simply click the pair option again. The new paired array will auto-populate in the model and, again, be displayed as a single source within the sources list. Selected arrays can be deleted by clicking the trash icon in the bottom right of the workspace or by simply hitting the delete key. And remember, Ctrl-Z or undo can be your friend here. The Enclosures tab is primarily used to define curvature of the array and includes all of the additional settings you need to modify when optimizing the array shape to meet your SPL over distance target. On the left side of the enclosures list, you will see the circuit links. These define how many enclosures share a common amplifier channel, or set of amplifier channels, in the case of multi-way loudspeakers. The setting for HR model determines what horn cert will be installed in the enclosure to define its horizontal coverage and determines the preset used in the signal processing chain. Meanwhile, near field correction, or NFC, applies attenuation to the high-frequency section of the selected enclosure. Since these settings directly tie to signal processing, when two or more enclosures share a common amplifier output, only the first one needs to change and the settings are applied to all other enclosures on the circuit. Finally, the display item determines the mechanical connection between adjacent enclosures to define the shape or curvature of the array. To access additional mechanical, weight, and load information for the array, click on the expand control between the multi-purpose panel and the studio views to expose the mechanical view. Here, you can view the total load on each pick point, their coordinates for the selected array, and the total array weight. A graphic indicates the overall array dimensions as well as the center of gravity for the array. The total load calculation includes the pullback assembly, span set, and come along and compression systems. The total load does not include any cable or hoist weight. The full set of rigging parameters are accessible within the Setup tab, such as slider position and pickup quantity. Notice that if the selected rigging parameters produce an array condition that is either unsafe or cannot be realized, then the array weight in the mechanical view is replaced with information about the error condition and, when unsafe, the load for each pick point is removed. Once resolved, the point loads are again displayed. Additional alert icons are displayed in the source list in association with the array. Once overall array physical settings are defined, you can apply processing to the entire array. All the Cohesion-specific array processing can be accessed in the Processing tab, including the Co-Series LF60 presets and array size overlays. In addition, gain and delay can be applied to the entire array during the system calibration workflow. This concludes our session on adding a line array to your system design. We covered many of the basics for adding, aiming, and working with line arrays within Canvas.